Hi everyone, welcome to the Earth Science Region to View podcast series created by the Homix Middle School Earth Science Department. Today we're going to focus our attention on page 5 in the reference table, your tectonics plate map. So before we get started, the numbers on the left and the numbers on the right, those are your latitude values. Numbers along the top and numbers along the bottom, those are your longitude values. The equator separates the Earth into northern and southern hemisphere. Your prime meridian separates your Earth into western and eastern hemisphere, maxing out at 180 degrees, your international dateline. Well, as you travel to the left of the prime meridian, that's your western hemisphere. As you travel to the right, that's going to be your eastern hemisphere, but you notice that the eastern hemisphere continues on the other side of the Earth. Okay, so you notice that very simply because your prime meridian is skewed to one side of the map. So just be aware of that with latitude and longitude. So let's start with our convergent plate boundary. Ocean to continent convergence takes place in the Pacific Northwest at the Juan de Fuca Plate and North American Plate. Juan de Fuca Plate is going to subduct underneath North America. The Cocos Plate is going to subduct underneath North America, and even the Caribbean Plate there as well. And you also have the Nazca Plate subducting underneath South America. So in these locations you have subduction, volcanoes, earthquakes, mountains, and trenches. Just in case you get a little bit mixed up, take a look at the map key at the bottom, okay, which is going to tell you the symbol between the overriding plate and the subducting plate, and also look at the arrows, tells you a little bit about relative plate motion. The next type of convergent plate boundary is ocean to ocean. Again, you're going to get the exact same features, except now those volcanic mountains are in the water. So you get the Pacific Plate subducting underneath the North American Plate to produce the Aleutian Islands. The Pacific Plate subducts underneath the Eurasian Plate to produce the Japanese Islands. The Pacific Plate subducts underneath the Philippine Plate to make the Marianas Islands, and the Philippine Plate subducts underneath the Eurasian Plate to make the Philippine Islands. The Indian-Australian Plate subducts underneath the Eurasian Plate to make the Indonesian Islands. And finally, to round out the Pacific Ocean here with convergence, okay, the Pacific Plate subducts underneath the Indian-Australian Plate to make the Tonga Islands. Now, the reason why the Pacific Ocean is called the Pacific Ring of Fire, because of all the subduction, major earthquakes, and major volcanoes that occur. And most of our earthquakes and volcanoes occur along plate boundaries. Now, we do have some ocean-to-ocean convergence at the somewhere in the Atlantic, where you have the North American Plate, the South American Plate, and the Caribbean Plate all somewhat interacting in that location, possibly ocean to ocean. And then also the South American Plate and the Sandwich Plate, you get a little bit of ocean to ocean there as well. The third type of convergent plate boundary is continent to continent. You get that with the Indian Plate crashing up into the Eurasian Plate, and you also have that here with the Arabian Plate crashing up into the Eurasian Plate. Okay, so very important to know your convergent plate boundaries. Next, we're going to move into our divergent boundaries. So your convergent boundaries, really, really violent volcanoes, really violent earthquakes. Divergent plate boundaries, okay, there's not as much friction, so you're not going to get as violent of features. Most of our mid-Atlantic ridge system or mid-ocean ridge system is going to occur underwater. So you have that location in the middle of the Atlantic called the Mid-Atlantic Ridge. In the Pacific, it's called the East Pacific Ridge. You see there's a number of divergent boundaries in that location, okay, based upon the Cocos Plate, the Nazca Plate, the Antarctic Plate, and the Pacific Plate. In the Indian Ocean, you have the Mid-Indian Ridge, you have the Southwest Indian Ridge, and the Southeast Indian Ridge. So multiple divergent boundaries there. We even have a little tiny one called the Juan de Fuca Ridge, where the Juan de Fuca Plate is moving away from the Pacific Plate. Okay, and we even have a teeny tiny ridge system there where the Sandwich Plate is moving away from the Scotia Plate. So again, look at the plate motion. It'll tell you what plates are moving away from each other. So if you need map key at the bottom, again, tells you the relative motion and the symbol for divergence. We have a couple locations where continents are splitting apart. Okay, that's what we call continental rifting. Iceland is one example where a continent is splitting apart. And the East African Rift is a zone where continents we believe are splitting apart, the eastern part of Africa. The last type of plate boundary is your transform. Probably the most common example of a transform plate boundary is the situation where the Pacific plate is sliding past the North American plate in California called the San Andreas Fault. But there are some other locations. Motion of side-by-side motion is going to take place between the African plate and the Antarctic plate. Side-by-side motion is going to take place between the Scotia plate, the South American plate, and the Antarctic plate. You can also get it here between the Indian Australian plate and the Pacific plate. It actually runs right through New Zealand. And also up here between the North American plate and the Caribbean plate as well. So if you get a little bit mixed up, there is your plate boundary in regards to the symbol. Make sure you notice the arrows and the direction of plate motion. That leads us to our dotted lines. These dotted lines represent complex or uncertain boundaries. Scientists don't know exactly what's going on. We believe the East African Rift is breaking apart, but like you see with the map symbol, you're not really exactly sure. We have another continuation on the other side of the map in regards to this region as well. Very, very active region. Again, not really exactly sure what's going on. We have another little one there, okay, to the eastern side of India. Okay, also up there in real eastern Asia. We have another one there at the bottom of the Caribbean plate, the boundary between the Caribbean plate and the South American plate. And again, you see the dotted line just represents the complex or uncertain plate boundary. Okay, we also have another teeny tiny one there just to the eastern side of the Caribbean plate as well. That leads to the last concept down here, and that's going to be hotspots, where magma is going to be found somewhat in the middle of a plate, in most cases, where the plate slides over top of that hotspot that's going to produce a volcanic mountain system, in most cases in the middle of a plate. So you have the Tasman hotspot, the Hawaiian hotspot, the Easter Island hotspot, the Yellowstone hotspot, the Galapagos hotspot, Iceland hotspot, Canary Island hotspot, the St. Helena hotspot, and the Bouvet hotspot. And again, if you get mixed up with the map symbol's right there at the bottom. So that's it for now for page 5 in the reference table. We'll see you soon.